Math 7, Unit 4, Graphing and Slope, Lesson 3, Part 2, Slopes of Parallel and Perpendicular Lines. First, let's consider the two special cases of horizontal and vertical lines. Now, about being parallel or perpendicular, the first thing to notice is that all horizontal lines are perpendicular to all vertical lines. So horizontal and vertical lines are perpendicular. The other thing that should be somewhat obvious is that all horizontal lines are parallel to all other horizontal lines, and as a nice corollary, all vertical lines are parallel to all other vertical lines. So if you have two horizontal lines, they're parallel. If you have two vertical lines, they're parallel. And horizontals and verticals are perpendicular. Just before we move on, just reminding you of some vocabulary. Parallel means they go on forever without touching. They basically go in the same exact direction. Because they're going in the same direction, they will never cross. Perpendicular means that, well, that would be you. Perpendicular means that they are at 90 degrees with each other. So if I were to draw a vertical and a horizontal line on the same graph, then they would form a right angle. That means perpendicular. So vertical lines and horizontal lines are perpendicular. Okay, let's take a look at these. These are parallel. We're going to make that claim right now that these are parallel. Okay, they go in the same direction. It actually, if we look at the slope of parallel lines, this is an up 1 and over 2, and I can do that as many times as I need. So the slope of this line is 1/2. This line also goes up 1 and over 2, so it has a slope of 1/2. So my first claim to you is that parallel lines have equal slope. And this should make sense. Slope tells you how steep something is, kind of gives you a direction it's going. So if you have two lines with the same slope, they're going in the same direction, they're the same steepness, they are going to be parallel. So the first thing is that parallel lines have equal slope. Okay, perpendicular lines. Here's a couple sets of perpendicular lines. Let's see what we can figure out. On this one, that's up 1 and over 3. So this has a slope of 1/3. This one goes down 3 and over 1. That has a slope of -3 over 1. Okay, I do notice that they have the same numbers, but one of them has a negative sign. Actually, it kind of makes sense one of them has to be negative slope. If they were both positive slope, there'd be no way for them to have a 90-degree angle between them. So one of them does have to be a negative slope. What happens here for perpendicular is that it's like a fraction flip. So if we take 1/3 and flip it, it's 3 over 1. And we change the sign. So perpendicular slopes are opposite. That changes the sign. Reciprocal. And reciprocal, if you remember, is putting a fraction upside down. So you flip the fraction and change the sign, and that gives you a perpendicular slope. On this one right here, up 1 over 1, the slope is 1. Here it's down 1 over 1, the slope is -1. 1 and -1 are opposite reciprocal. Another way you can think about opposite reciprocals, when multiplied together, always give -1. Here you can see -3 times 1/3 is -1. -1 times 1 is -1. Perpendicular slopes, when multiplied, always give -1. Okay, is the parallelogram a rectangle? Justify your answer. All right, If this parallelogram is a rectangle, then the sides will be perpendicular. You have to have 90-degree angles. Well, the slope of each of these sides, this side is up 1 over 1. It has a slope of 1. And this one down here parallel to it also has a slope of 1. Right here, this is a slope of -1 over 1, which is -1. And this is a slope of -1. So if we compare these slopes, they are perpendicular. So line JM is actually perpendicular to line JK. And if we check all the others, they are also perpendicular. So yes, it is a rectangle, and it's because the sides are perpendicular. Well, adjacent sides. Adjacent sides are perpendicular. So yeah, it's a rectangle. All right, in your practice, you're going to have to find the slope 6 times here between 2 sets of points. It looks like you've got some bigger numbers here on C, but that shouldn't matter. You just do the same process. Number 2, identify all pairs of lines that are parallel and or perpendicular. If there are no pairs, write none. If there are 2 pairs of lines, list both. Okay, so you're identifying parallel and perpendicular. You're going to want to find the slopes of those lines and then compare them. Number 3, the given data below represents the shipping of toys by 2 toy manufacturers. So you've got some information in a graph and information in a table, and you're going to make some comparisons. The idea here is you can find the slope in both forms, and then the slope is the unit right here. You can make some comparisons. Number 4 is a review of slope as far as pitch is concerned. Number 5, find the slope between 2 points. It's got some fractions there, but you'll still follow the same process. Number 6, identify the transformation that maps line segment AB onto line segment CD. And number 7, I'm giving you 3 points, and I ask if they're in the same line. Without drawing a graph, how could you know they're in the same line? Think about that. Number 8, the vertices of a parallelogram are given here. That's supposed to be a comma after the 5. And you're going to plot them, and you'll do it just like the example we saw. If it is a rectangle, then it'll have perpendicular sides. If not, it won't.